Hi, welcome. We are going to do section 4.18 today, the last section in chapter 4, which is kind of exciting. And it is called scatter plots. And it's a fairly easy one, but it's got some interesting ideas. I'm going to be using, I printed off a copy of all of the pages in the section because I'm going to use a lot of the drawings and examples from it. My expectation is that you only write what I write. So you have to write that because I wrote it, right? Makes sense. All right. So scatter plots. This is when we're going to be referring to like points with a lot of data on it. In this section, they have this cool graph, and this graph is the observed annual average global temperatures. Now you don't have to write this because you don't have a copy of this graph. And over here it says the year that we're looking at. So it starts at 1880, if you can't see that, and it ends up at 2020. Now we haven't been to 2020 yet, so you can see that there's not data that fills completely that direction. Over here is degrees Celsius, so not Fahrenheit but Celsius, and Celsius degrees, and it's showing us what the average temperature is over the whole world. And the question is there a correlation with, as time passing, is the Earth getting warmer? And you could use this data to suggest one way or the other. And we're going to be talking today about taking these scatter plots, where there's a whole bunch of data all over the place, and seeing if there is what we call a correlation. So we are going to be, let me find my other page, looking for a correlation. Now I can never spell this word right, so let me see if I can find one quick so I don't ruin it. Yeah. Correlation simply means that if I do something to one thing to one variable, the other will either rise with it or rise opposite to it. And we're seeing if they are connected. So the two variables that we're looking to see are connected here are time, measured in years, and the degrees. So the question is, over time, does it go up? And what we'll see is that we can kind of do a best fit data and kind of look, if we kind of average all these points together, how does it go? And you could see that I kind of can make a little line like this. Now mine is not perfect, but there's computer models that you can use to build you like exactly the accurate line that it would be going on. So this would suggest that the Earth is getting warmer over time. But we would, of course, need a lot more data to show or to prove or to suppose that that hypothesis is correct. So let's take a look more at these scatter plots. Oops, I want back to my writing page. And there are three kinds of correlations. We have, we're going to draw little miniature graphs. We're going to have, let's see, 1, 2, 3. All right. One kind is a positive relationship. Aw, they're really good friends. No, it doesn't mean that at all. It means that as I increase one variable, if I start to plot these points, I can see that it looks like they go up. If I were to draw my best fit line through here, it would be like this. And I can see that as one goes better, they both kind of correlate up. Another way that this can happen is that I can have a negative relationship. This is not a bad relationship. It is merely negative, like how we've been talking about in integers. I don't know why I would say it like that. And instead of looking like this, it might start here and then go down. Often there's points that don't quite fit in, which is totally normal and totally fine. And you can see here that it starts up one part, and over time, it goes down. So if we had global cooling and I was plotting the data, it would start up and it would go down. And then lastly, we have one that we call no relationship. And this simply looks like this. There is clearly no best fit here, and it doesn't even look like these data points are particularly correlated to anything, because I can't really make a best fit, and even if I did average them all together, it would not be particularly useful. And we can refer to these also as positive relationship / correlation, just like we did before. So this, I want to write this line of best fit. And that is the line that you get when you average the points. All right, we are going to build a quick table, and we're going to build this. I want you guys to do it in your notes, because building tables like this is a good practice. And this is what it's going to look like. Now, this one does not have to be perfect at all, of course, but it's a good way to start. So I have a graph here, and we are going to be using data for hours worked on a test. Now, I know we don't really do tests here, but I think you kind of understand the idea of tests. And the grade that students got. And we're going to see if the data that, as students worked more time, did that correlate and did that fit with getting a better grade. So here's our data, and I will, let's see, how can I get this to show up on both? Can I put it like this? Let's see if I scoot this up a little bit. Sorry, one second. I can put this, there we go. All right, so now we need to put our data in. We're gonna go hours worked. Looks like 1 to 5. So let's go 0, 1, 2, 3, 4, 5. I should have spaced it out a little bit more. Grade, we have 90 down to about 60. Okay, so we'll go up to 100. Actually, let's go down to here. 90, 80, 70, 60. And then what I'll do is I'm going to put a little break in my graph right here. And that shows that I don't need to go all the way down to 0, that this part isn't exactly to scale. And let's start graphing these. Okay, we have Ahmed. He did 5 hours and he got a 90. I'm going to do these in a different color. Worked for 5 hours, got a 90. Becky, number of hours, she worked 3 hours and she got an 80. 3 hours, got an 80. Daryl worked 3.5 hours, got an 80. Emma worked 1 hour, got a 60. 1 hour, got a 60. Oops, about there. Guillermo worked 4.5 hours, got a 90. 4.5. Helen got 1 hour to 70, 1 hour to 70. Kiet, 3 hours to 75, 3 hours to 75. Nishka, 4 hours to an 85, 4 hours to an 85. Ali, 2 hours to a 70, 2 hours to 70. And Zivia, 2.5 hours to 75. Okay, now we can look at our data like that, and it certainly does look like a correlation, because I could draw a best fit graph kind of through here. And this would suggest that the more hours students worked on this test, the better grade. Oh, I'll move this in case you want to build your data. The more hours spent correlate to a better grade. If the relationship looked more like this, I could say that no, there's no relationship. Don't study for a test because it doesn't help. I could say that the more you study, the less well you do on your test. That would probably not be a very good test. But here, I do see a positive relationship. Over the hours worked, a better grade does happen. Okay? Makes sense? Now, you are going to be using this style to look at some more graphs, and you're going to be answering questions related to these things. I'll just show you a couple more. For example, in this example, they ask you to graph these ordered pairs. Now, we're not going to do another graph because we did one already. But this is kind of what it looks like. And the question is this positive, negative, or no relationship? And it definitely looks to me like a positive relationship. Because if I draw that line out, I can see that over time, it gets perfect, or it gets better. Now, the line is not perfect, of course, because this one's above, this one's below. But overall, I can see that it's in that general direction, and it's certainly trending that way. Again, look at this graph. You graph some ordered pairs, and if I was going to say if this was positive, negative, or no relationship, this definitely looks like a no relationship. So I could certainly draw a line like this, but these points are way out, and I'm not sure that I would really say this is a positive or a negative one. This definitely looks like no correlation. Okay, so for your homework, you're going to have a graph that looks like this, and you're going to have some questions to answer related to it. After that, you're going to build your own graph like we did earlier, and answer some more questions about that. And good luck. If you like this, make sure you subscribe, and thanks.